Hello everyone and welcome to another video. Today we're doing a Leetcode easy question about trees. And this time we have to determine if a tree is height balanced. So as per the definition, a tree is defined as height balanced if the left and right subtrees of every node differ in height by no more than 1. So let's take a look at the examples given. So for example 1, let's just say that at the base level, the height will be 1. Okay, so for 15 and 7 here, they have a height of 1. Oops, sorry. So for 15 and 7 here, they have a height of 1. So for the height of 20, it will be the maximum between the height between the left and the right subtree. And since both of them are 1, this will be 2. And then for 9, in this case, you have a height of 1 since it's a leaf. And finally, the height of 3 is the maximum between the left and the right. So it will be 2 plus 1, which is 3. So as you can see right here, the output return is true because each of the nodes in the left and right, because for the node, the left and right subtrees only differ in height by no more than 1. Taking a look at example 2, you see that the 4s here have a height of 1, which means this tree has a height of 2, and the right number 3 here has a height of 1, and this means that the left number 2 has a height of 3 because 2 plus 1. And when we take a look at the right side, you see that the 2 has a height of 1. And lastly, for the root node right here, the 1, it has a height of 4. So as you can see right here, you see that this example 2 right here, the tree is unbalanced due to these values right here. Because the left and right subtree of the node at 1 differ in height by more than 1, which is 2. So as such, the output is false. And for a trivial case where we are given an empty node, we will return true. Okay, so hopefully you have understood the question right here. Okay, so the way I see this is that firstly, the output they want me to return is truly or is either true or false. However, in order to check the heights given, to see if they are height balanced or not, I have to look at integers because they are heights. So this can bring me the idea of creating a helper function. Okay, so maybe I'll have a global variable called balanced, and then inside this I'll have a helper function. And what this helper function will do is to help me check if I meet any imbalance in the height. So initially, I'll set balance to be true. And inside this function right here, if I meet imbalance, then what this does is it will simply make this balance right here to become false when I meet an imbalance. So that'll be how the general algorithm will work. So what this helper function does, what it will do is that it will simply be I'll make it into a recursive function, and it will just at every point help me check if its left and right subtrees are balanced. So this will be how the helper function will work. Okay, so it will take in a node. So basically, for the very trivial case whereby I don't have any node. So if my node is none, I'll simply just return 0 because an empty node will not have any height. But else, what I will do is that I will have to recurse down the left and right subtrees in order to get the height. So the left height will be helper function called on the left of the node. Okay, but the right one, the right height, is a helper function as well, but this time code on the right of the node. Okay, so what this does is that by recursion, this will give me the left height of the current node that I'm looking at, the subtree, while this will give me the right height of the current node I'm looking at, the right subtree. So finally, what I have to do is to just simply compare if the absolute difference between the left and the right is greater than 1. So if the absolute difference is more than 1, what this simply does is to, like what I said just now, it will change this right here to become false. Okay? Else, if not, what I need to do is that I have to return the updated height. so that when the value comes back, it can continue to check the higher levels of the tree. So first I need to take note. So as what I mentioned just now, when you take a look at the nodes, for example, the height will be the maximum of the left and the right subtree plus 1, because we need to add 1 to the next level of the height. So what this will be, it will be a maximum of the left and the right subtree's height added to 1 in. So that will be the height. So this will be how the general algorithm will run. So in this case right here, since I've originally set my balance to be true, this means that if this condition is never met, and I never set my balance to become false, then that will mean that my balance will still be true. So at the end of this, all I need to do is just run the helper function on the root node, and after that return balance. Because if it is indeed imbalanced, it will have been set to false at this point in time to return me the answer. So let's just run this algorithm as on maybe example 2, and I can take a look. So let's refer to example 2. So at this root node right here, I'll run helper function on this, okay, on the node 1. So it will check. If it's none, it will return 0, but else it will recurse on the left and the right. So it recurse, and it's still not none, so you'll continue. So what you'll do is look at the left side one first, and you'll recurse, and still looking at the left, you'll continue to recurse. And finally, it will be at 4. Then it still continues to recurse, because it needs to check, because at this stage, the 4s here are still not none. So at this point in time, finally I meet the none values right here. Alright, so what this will do is that it will return me 0 as expected. So I'll just use another color, so it'll be 0 and 0. Then now I can take a look at 4. So is the absolute between these two more than 1? It's not, right, because 0 minus 0 is just 0. So I'll just return max of LR plus 1. So my 4 right here will have a value of 1. And then we can take a look at the right side now. So same thing, this 4 also has a 1, because it's the same case as the left one here. Then finally, it will continue to recurse up. So it's 1 minus 1 greater than 1. It's not, right? So 3 will have a height of the maximum between the left and right subtrees, which are both 1. So it'll be 1 plus 1, which is 2. And then now I continue to look up at 3. So this is right here also 1, because of it's a leaf node right here, which has a similar base case, which has a similar analysis of the node 4 right here. So again, I'll just check, is 2 minus 1 greater than 1? It's not. Then I'll go to the else. So for this 2 right here, you have a height of 2 plus 1, which is 3. Because 2 is a higher value of these two subtrees respectively. And finally, I'll take a look at 2. So likewise, it has a height of 1. And then I'll check, is 3 minus 1 greater than 1? It is, right, because it's more than 2. And as such, balance will be set to false. Then it continues to look up, whereby 1 will now have a height of 4. So in this case, I will have set my value to become false. And now finally, I'll return it and get the output of false. So this will be how the general algorithm will run. So now let's move on to the coding part of the solution. Okay, so now let's move on to the coding part of the solution. So as always, let's start with some pseudocode first. So we have a Boolean variable of whether the tree is balanced. And next up, I need a helper function to help me check for imbalance. Finally, I will run the helper function and return the variable. Okay, so let's now have a global variable initialized. Okay, so for this part, I'm gonna assign it to an array actually, because I don't know how to actually refer to this variable right here inside the helper function, because it will treat this, because if you use it inside helper function just as a primitive variable, it will take it as we haven't defined anything yet. So this is my in a sense my band-aid method to fix it now. We can also use non-local, but for some reason it's not working.
And in general, this is actually kind of bad code practice, but I don't really have a resolution for this yet. So this is what I'm just going to use for now. So now let's define the helper function. We shall take in a node. So like what I checked just now, if none, return 0. Else, I have to recurse on the left and right to get the height. Check the difference in height. And if more than 1, set balance to false. After that, I'll return the maximum height between left and right and add 1 to it to increase the height. So this will be how my helper function will run. So if node is none, I simply return 0. Else, I will recurse on the left, the right as well, the right. Oops, this should be height. After that, I'll calculate the difference to see it's more than 1. For this right here, we can just use the absolute inbuilt function right here to help us to get the positive value. Then we can check if the difference is more than 1, then I'll set balance to be false. In this case, I'm referring to the 0 index right here in order to reach this part of the code. Then after that, I'll simply return the maximum between the left and the right height and add 1 to it. So this will be how the algorithm will run. So as for the pseudocode, I need to run the helper function. And finally, I can just return balance, the 0 index, because that's where it will hold my boolean value. So yeah, this is how the code should run. So for the time space complexity, I believe that the runtime is going to be O of n, where n is the size of the tree, because we have to traverse and look at every node actually. So this is for the runtime. And for the space complexity, if you look at the recursion stack depth, it's going to be a ON as well, because we have to recurse to we have to recurse to every part of the tree. So yeah, I think the solution should work, and this is how I will code it out. Solution does work, and yeah, if you have any questions, then feel free to leave it in the comments down below. Or else, if not, then thanks for watching and see you guys next time, or soon, I guess.